Did you know some of the most powerful AI models today learn directly from vast amounts of unlabeled data, not by predicting outputs, but by discerning relationships between different views of the same input? This isn't magic, it's a technique called contrastive learning within self-supervised learning. It empowers machines to understand the world by establishing what's similar and what's fundamentally different without human-provided labels. Imagine you have a single photograph. Contrastive learning first creates two slightly altered versions of that photo, say one cropped differently and another with a color shift. These two augmented images are considered a positive pair. They represent the same underlying content. The core idea is simple: pull these positive pairs closer together in the model's learned embedding space, meanwhile push them far away from many other randomly chosen augmented images, which are deemed negative pairs. This process is driven by a contrastive loss function, which encourages the model to learn features that are invariant to the augmentations for the same image, yet highly discriminative between different images. So an AI doesn't just see a cat, it understands what makes that specific cat distinct from all other cats or any other object, even when the lighting or angle changes. Its real-world impact is profound. Consider medical imaging, where labeled data for rare diseases is incredibly scarce and expensive. Contrastive learning allows models to pre-train on millions of unlabeled scans, learning robust transferable features before fine-tuning with a tiny labeled dataset. This significantly outperforms traditional supervised learning in data-scarce scenarios, where models often overfit or fail to generalize, unlike older unsupervised methods like autoencoders, which might reconstruct input without truly understanding semantic content. Contrastive learning forces the model to capture high-level discriminative semantics. One lesser-known nuance is the critical role of hard negatives. The more challenging the negative examples are to distinguish from the positive, the richer and more discriminative the learned representations become. This often requires sophisticated sampling strategies or large batch sizes. This shift from explicit labeling to implicit understanding unlocks AI's ability to learn from the sheer abundance of raw data. It represents a powerful paradigm shift, making AI more autonomous, scalable, and adaptable to real-world complexities where labels are a luxury, not a given. References: Chen T. Kornblith S. Noruzi M. Hinton G. 2020, A Simple Framework for Contrastive Learning of Visual Representations, International Conference on Machine Learning. If you want to support the channel, you don't have to cough. Ihasambalaha.